Welcome to this presentation on how connected data can help make project delivery more efficient. I'm going to be using the M42 J6 as an example for this. First of all, please let me introduce myself. My name is Tom Denby. I'm currently the BIM manager for the M42 J6. Previous to this, I've worked in a wide range of construction projects, from commercial buildings through to utilities and rail. I've always been driven to find project efficiencies, especially if it means replacing repetitive tasks and decreasing the likelihood of human error and increasing productivity. Now, let me quickly give you a project overview. The M42 J6 is part of Highway England's Regional Delivery Partnership Scheme. The works for this project include a new 2.4 kilometre dual carriageway link road, a new junction at the M42 motorway junction 5A, new pedestrian footbridge over the A45, demolition of existing roads, overbridge and construction of new bridges to replace them, realignment of existing local road networks, plus more. For those who are familiar with the Midlands, project primarily near Birmingham Airport and the NEC, we set out looking for what it was we wanted to achieve and to understand what would really help the project be delivered more efficiently. With that in mind, we came up with the following objectives. As you will see, the challenges we will be facing are connecting large data sets that out of the box don't talk to one another. We set the goal to make the data and information more accessible than ever before by making it consumable on any device, provided you have internet or data connectivity. In order to do this, we needed to, first of all, reduce any manual steps. Secondly, understand exactly what it was that the team wanted to do with the information and what they wanted to get out of the information. And thirdly, we need to try and standardize our development so that all development was reusable in the future for future projects. Before we go into the detail, I want to give you a high-level overview of the processes of how information and data is collected on the project. First of all, we have the project CDE, ProjectWise in this case. Then alongside that, we have numerous systems such as BIM 360 Field, Primavera, PowerBI, Scansky Maps, which is our primary GIS system, plus many more. Where data, in all these places, data is being collected. At some point in time, the data that is collected from these sources will need to be transferred over to the CDE, ready for handover to our client. So there's the first challenge. It is great that we are now able to collect data more digitally. It means we can standardize how we collect data, and also there is no problems understanding the information that's being collected. But how do we ultimately get it stored in the CDE at the right point in time so we don't cause any program delays? Then on top of that requirement, different disciplines want to overlay their data to utilize the information as effectively as possible for them. I've chosen 5 ways a user can interpret the information, and those are PowerBI, Scansky Maps, Scansky BIM Viewer, and 5D and 4D processors. The first and most accessible way of consuming the project's information is by using the Scansky BIM Viewer. You can see on the background of this slide what the solution looks like. It is a basic read-only way for anyone to access the latest project's federated model that's stored on ProjectWise, or for that matter, any CDE. Now let's look at some of the processes and considerations that made this achievable. First thing to understand was the project's requirement for this tool. As you can see from the line along the top, there was one main requirement. They wanted to be able to access the latest project federated model in no more than 2 clicks from any device, from anywhere. Now let's talk about the process of what that meant to them and then how we achieved it. So what they really wanted was, they wanted a web-based viewer that they could access via a URL link. They also would like the possibility to also have a viewer within Power BI, as well as the metadata being a data source in Power BI. So really it was 3 requirements, not 2. The web-based project viewer showing the latest information, that's fine. And the viewer would show the same information but only accessible via via dashboards. In order to achieve this, we took the following steps. Understand where the data needs to be hosted in order for the viewer to work, and also for us to comply with any of our clients' requirements. And what the pros and cons of these 2 locations were, primarily US-based server or EU-based server. If the project CDE isn't an Autodesk system, how do we make it accessible, or how do we make the model accessible from this system to the Forge Viewer API? This was the API we used to develop the viewer. How do we secure the URL without having to add more usernames and passwords for people to remember? Where is the best place for Skanska to host the viewer? And finally, how do we best manage future developments of the viewer without disrupting the live project viewer? The process I will take you through now is high level, but I'm hoping it will give you an understanding of how we achieved the following. First of all, we have the project CDE. We need to understand that's location, and in our case, it was ProjectWise, which isn't an Autodesk system. So therefore, we had to get it to an Autodesk bucket to enable the viewer to access the latest model. In order to do this, we used Azure Shell script that monitors ProjectWise and pulls the model over into the bucket. This uses both Bentley and Forge APIs in order to do this. We then develop the code for the viewer, which references the models that are stored in the Autodesk bucket. This will then mean that when we come to viewing the model, we'll have access to any of the models stored in that bucket. And then finally, this is how the user consumes it. So it's just a simple URL with a list of projects along the top, and they click on the project they require. Now, we needed to secure that. We did this by using Microsoft's MFA system. Through our in-house IT processes, we were able to enable it on the website. And we also meant that we could give our supply chain on projects access to the viewer. So there were 2 levels of security. First of all was access to the URL. This was done via MFA. And then secondly, there was access to your project. We don't want anyone having access to any project. So we created Azure Active Directory security groups to enable this. So you could only view your project's information. Next, we went about creating the Power BI custom visual. Again, this was a Forge development. There's actually a tutorial on the sort of skeleton to this that the Forge team have posted online, well worth a look at. But it references the same model. So 2 different viewers always looking at the same model, which is important so that we get continuity and everyone's always looking at the same information. And then custom visual works like any other visual does in Power BI. You can select data in other infographics and it'll filter what you see in the viewer and vice versa. So that was 2 of them. However, there was a 3rd requirement. They also wanted the metadata from the project federated model as a data source in Power BI so they could then start to cross-reference it. So in order to do this, there is a process where once the model is in the Autodesk bucket, we're able to then download that model as a database file. So we download the DB file of the model. We then load that into our SQL server, and we can then reference that data back into Power BI. So now we have the graphical and non-graphical information that relate to that model. With that, along with other third-party data sources, which you can see on the right-hand side, these are some of the ones we use, we're then able to start cross-referencing. And we have a project taxonomy which we use, which I'll talk a little bit about later on, but that basically standardizes how we can make all the different data sources, items, speak to each other. With all of those processes happening in the background, that means we now have two clean and easy ways to access the project's federated model. One, we have a web-based viewer displaying the required data and fully controlled by Skanska, meaning we can tailor it to any of our future needs, and as project delivery gets more demanding, we can make the viewer reflect that. And then secondly, we have a powerful PowerBI viewer that will filter and work like any other visual, and again, enable people to view data in a more graphical way. Now let's talk about our 4D process. The image you can see in the background is Synchro Control. This is a cloud service that we are currently using to enable cloud-based 4D delivery on our project. As you can see from the graphic, Synchro Control, or in this case the cloud-hosted 4D data, is connected directly to our project CDE ProjectWise. This means that we no longer have to worry about offline copies in order to create our 4D models. We can link it directly to the latest design information, and either automatically or manually we're able to set the system up so that we can update those models that we see in Synchro. Synchro is then linked directly into the Synchro Control, which is a cloud-hosted element of it. So the desktop tool is linked directly into that to pull down the model information. Our program data, in this case P6, is linked directly into Synchro, and then Synchro can push and pull information between one another. This means that we now have a full read-only access copy of the 4D sequence stored in the cloud. This can be accessed in a web browser. We're able to give people on the project web browser access and login passwords and whatever, but it also makes it more accessible by other devices. So again, the image in the top right hand corner is PowerBI. You can see that we've used the Forge development we talked about in the last set of slides to enable us to visualize the program a little bit more. So when we select a program in our Gantt chart, it'll highlight the element in the Forge viewer. And then it'll also give us all the other data that we've cross-referenced with it. We're also able to link it to iPads and apps, and even AR technology if required. As well as all of these out-of-the-box features, there's also open APIs that mean, if required, we could fully develop our own solution in order to collect this data. But because it's cloud-hosted, it is much easier to get access to that information. Now let's talk about our 5D process. The background to this slide is Costos. This is the software we use to produce our 5D bill. Before we can even think about producing the 5D bill though, there's a process we need to go through in order to make this information as reliable as possible. And now I'm going to talk you through that process. First step is to understand the data we have and how that information is structured. We do this by collecting old bill of quantities and using this to populate our first version of our 5D library. Our 5D library is basically a standardized database of all the components that we know about and any information we know about them. As well as this, we also have our standard taxonomy that I mentioned earlier on, that is used on this project, but it's also used on all projects. This is a standard coding structure that is given to all elements to ensure that all the various parties are naming the elements in the same way, whether it be cost, commercial, planning, design. It's a requirement that everyone has to follow. This enables us to easily be able to cross-reference commercial planning, design information, as well as mapping our rule sets in Costos to this dataset. Once we have this information, we use all three to inform the project how to structure its LOD and LOI matrices. This will then in turn dictate the structure of the 3D model and the deliverables we require from all the various parties. And using tools such as PowerBI and Assemble, we can really easily check that the design files are following their precise naming conventions and data structures. Once we are happy that the model is following the structure, we can begin to populate our 5D bill. This is done using Costos by mapping our taxonomy to the bill methods of measurement. Once the bill is produced, we have a checking process to ensure that it is accurate as possible. We identify any gaps and anomalies and update the 5D library accordingly so future bills won't have the same mistakes or gaps. By following these steps over a period of time, we are able to more accurately and more efficiently produce bill of quantities in the future. Although this is a process that will mature with time, we are seeing real benefits using this process now. Next, I would like to talk about Scansky Maps. Scansky Maps is our in-house GIS platform that enables our teams and partners to access design and geospatial data from anywhere. The platform is powered by Esri, as you will see on the process map over the next few slides. The first thing we need is a central repository to store all the data that is accessible by Scansky Maps. For this we use Esri ArcGIS Enterprise as our front end. This is where we can store all of our information we want to publish. We now need to identify the sources of all the data that we will overlay in our GIS platform. Firstly, we have our external data sources. This could include anything really, but it usually includes the following: third-party information, maybe environmental, health and safety. Customer data, this could be legacy information from previous schemes, and any other known legacy data. Next, we need to import and link it to our design information. To do this, we link it to the project CDE, as well as any design information not hosted in the CDE. This could be GIS data from our design partners' systems. All this data needs managing and bringing together, as well as updating on a regular basis. To make sure that Scansky Maps is displaying the latest information and make it useful to the project, we use FME workbenches to regularly run the processes of collecting all this information, publishing it to our geospatial CDE, and then enabling our users to consume this data. We then have tools that are used to interact with this information. Primarily, we use Scansky Maps, but we do also have the ability to access it via desktop GIS, as well as increasing demand around field GIS apps as well. And last but not least, We have a series of quality checks to ensure that any GIS data we are using on the project and planning on handing over is structured in a manner that meets our handover and deliverable requirements. PowerBI. If you would like to find out more about how Skanska are working with Esri to enable projects to get the most out of these platforms, my colleagues Georgios, Balash and Anita, along with Esri's team, will be doing a panel discussion. I will put the links in the chat as well as the handout documentation, but it would be well worth listening to that. I hope you have found it useful, and if you have any questions, please put them in the comments. If you have enjoyed, please like and share it.